Hello and welcome to the next video. So we have set up the running functionality. As you guys can see, our character properly runs start, run loop and run stop in any direction properly, and we can also perform pivoting functionality, as you guys can see. So now let's move on and implement the walking functionality. So for walking, I'm gonna first open my blueprint, character blueprint, and I'm gonna use the caps lock key and flip flop. Sorry, I'm gonna get this flip flop. So when we press caps lock, we'll enter the walking mode, and when we press caps lock again, we'll enter the running mode. So it's basically flip flop between walking and running. And from walking, I'm gonna get my character movement component and set max walk speed, and also I'm gonna set the acceleration, max acceleration, and I'm gonna duplicate it for running as well. There we go. So let me check my notes real quick. So when we entered the walking, we'll set the max walk speed to 160 and set the acceleration to 350. And when we entered the running, we'll set the walk speed to 450 and acceleration to 1000. There we go. So now if I press caps lock, you can see my character goes into walking state. Alright, now I'm gonna open up the animation blueprint. Here we have the base animation, base locomotion layer, cycle. Alright, so we have the locomotion first, locomotion layer, where we have the idle and movement. So from movement, we'll go towards first start, and then from cycle towards cycle state. So when we are in cycle state, let's say, I'm gonna open it up real quick and I'm gonna add a new state. I'm gonna add a standing. So if we are in standing state, definitely we'll add crouching next. So we'll add crouching state as well next. So right now we are in standing state. So when we are in standing state, I'm gonna cut this state from here. I'm gonna add a new state machine. I'm gonna call this cycle state machine. There we go. And over here we have the, I'm gonna paste it over here. This will be our run cycle, and I'm gonna add a new state. This will be our walk cycle. This is our walking and running states are set up. Everything fine. As we have set up our function for find locomotion state, so it will properly tell our character whether our character is in walking or running state. I'm gonna real quick print string and show you guys the result. Print string and get locomotion state. I'm gonna print it over here. So now you can see our character is running. When I press caps lock, our character goes into walk, run. That's it. Alright, so when we are, so by default we are in running state. So when we go to walk, if our locomotion state is equal to walk, we'll transition towards the walking, and similarly transition towards run if our locomotion state is run. There we go. I'm gonna set the blend time to 0.3, and for the walk cycle we need the animation, so I'm gonna open the echoes animation, and we have the walk forward. So in our previous video we have already applied the fit sync markers. These are sync markers and these are the curves. So for walking forward we don't need rotation curve here, and we need a constant moving speed which is 168. I'm gonna set it to 160 because in our end character blueprint we have set the speed to 160. So our moving speed for walking is 160, and curve over here, and similarly when our run cycle executes we set the rotation curve to 1, and for the walking as well we set the rotation curve to 1, and we need to apply the walk animation over here. This is the walk animation. For the sync groups, I'm gonna copy the sync group name from here, from running locomotion, and add it over here. Set the sync group to sync group, and also the play rate I'm gonna expose the pin and set it to play rate. There we go. Now our character can transition from run cycle to walk cycle. Let's play and test it out. So now our character enters the run cycle state. If I press caps lock, our character goes into walk cycle, goes through running. Okay, this works fine now. Okay. Let me really quickly check the notes. Okay, this is fine. Sync group is fine. We need to set the walk forward loop animation to true, and that's it. Now if we run, now it looks fine. Our character now properly transition from walk to run, and the animation blending is totally fine now. Okay, next we need to set up the start animation. As we have the base locomotion layer, cycle state is ready, and now we need to set up the start state. So similarly for start, I'm gonna remove this node and add a one node here, add a state which is standing, because our character is in standing state right now. Standing. I'm gonna cut these states from here. Open the state machine, create a new state machine, and call it start standing start state machine. Open it up, and here we'll have the two states again, one for run and one for walk. By default we'll go and run. I'm gonna open the run again and add a new state machine for running as well. This will be our run state machine. And now I'm gonna place the nodes over here, copy and paste the nodes over here, which is our start and then cycle state. So here we have the start, and we'll play the run start animation, then we'll transition towards the most recent state, which is the cycle. Transition toward the cycle state. I'm gonna copy these from here again and open the walk state and create a new state machine, call it walk state machine, open it up and paste the nodes over here as well. For the start, we'll play the start walk start animation, then transition towards the cycles animation. So here remember we'll create the thread save function for getting the proper walk start animation, run start animation, and here we have that function. So we just need to duplicate that function, and based upon our movement direction, we'll set up the proper walk start animation. So here we have the state nodes function. I'm gonna duplicate the run start. I'm gonna call it find walk start animation. There we go. And here we just need to connect the right animations. So here we have idle to walk forward. I'm gonna connect it over here, forward. Next we have forward left 90, set it to the left, and then we have the left 180. I'm gonna set it to backward left. Then we have the right 90. I'm gonna set it to right, and then we have the right 180, and then I'm gonna set it to backward right. So I'll set all the animations. So we have the forward start, 90 left, 90 right, and 180 right and 180 left, these 5 animations. So if I open all of the animations, we have all the sync markers and the required moving speed curve and the rotation curve. So for idle to walk forward, we have the rotation curve is at 0, 0. I'm gonna set a key and at 0.35 and set the curve value to 1. Similarly, as we have set up that for idle to jog forward, because this is our walk forward animation, therefore we don't have any rotation values to our root bone. So that's why we have manually add the 0 to 1 curve towards in the just idle to walk forward animations, walk forward, runs forward animations. So here we have idle to walk forward animation ready, and if I open up the forward left 90, you can see we have the sync markers, moving speed and rotation curves already applied. So we extract the rotation of our root bone and map that rotation into a 0 to 1 curve to each the animations. See, so this works fine for all the cases. And now we have the walk state. We transition towards start, and instead of using the find run start animation, I'm gonna connect to find walk start animations, because this is our walking state. So we'll use the thread save function for find walk start animations. This will give the proper walk start animation, and after that we'll transition towards the cycle state. That's it. Okay, so if I open my standing state machine, start state machine, ending. So we need to apply the transition logic from run to walk. So this will again be same as the cycle state. So if our get locomotion state is equal to walk, we will transition towards the walking, and if our locomotion state is equal to run, we'll transition towards the run state. That's it. I'm gonna set the blend time to 0.35. There we go. So now let's play and test it out. So if I press caps lock, our character is in walking state, but it doesn't perform any walking animations because we have here the track locomotion state functionality. So currently we are tracking only idle and run locomotion state, so we also need to track the walking state as well. So it will be pretty simple. I'm gonna duplicate the run track and paste it over here and add a new sequence, connect it over here. That's it. And for tracking the walking state, I'm gonna set it over here, the track the walking state. All right, so when we are entering the walk state, we need to run the function which is update on walk enter. So here we have the update on run enter function. I'm gonna duplicate the same function. So here we have update on run enter. I'm gonna duplicate it and call it update on walk enter. That's it. And all the remaining functionality, I guess, for the time being would be same. I'm gonna put the update on walk enter function over here, and while we are in walking state, we need to update our animation play rate based upon our moving speed animation curve. So this is the functionality for that. So now we have the logic for tracking idle, run and walking, these three states. So now if I hit play and go into walking state, see our character properly perform the walk start animation and blends towards the walk cycle animation. And see, you can notice there is not any feet sliding involved when turning, when transition towards the cycle state. So this looks pretty good and looks also pretty natural. Our character properly turned towards the input direction with proper start animation. So now one thing is remaining, we need to add the walk stop animations. So next we'll add that. So for setting up the walk stop animation, I'm gonna open up the animation blueprint again, go to the base locomotion layer, and in our locomotion state machine we have the idle state. So when we are stopping, we need to transition towards the idle because our locomotion state turns towards idle. So I'm gonna open the idle state again. Let me open my notes real quick. I'm gonna open the idle state machine, and here we have enter, run stop and walk, idle. So for this I'm gonna just a moment. Idle state machine, we need, I'll create a new state for stop state. That's it. Now remove everything else. So here we'll have the stop state. So when we enter towards the idle, we need to perform the stop functionality first. So stop, and in our stop state I'm gonna open it up and I'm gonna add a new state machine. This will be our stop state machine. I'm gonna open it up. So here we have run stop. I'm gonna copy it from here and paste it over here. We have run stop and we need also walk stop. Two states for stopping and one for entry. So when we enter the stop state, either we need to perform the walk stop or run stop. So for run stop I'm gonna add a transition over here and transition over here. So I'm gonna set the priority order to first check the run stop, set the priority order to 1, and if that becomes false we need to perform the walk stop, and I'm gonna set the priority order to 2 for this. And the condition would be if our get speed, so if our speed is greater than 200, we'll perform the run stop. So if that condition becomes false, we'll only left with one condition, which is perform the walk stop. So for that I'm gonna set the condition to true so that it can transition towards the walk stop, which looks really good. When we play the game, our character just perform a little stop animation and it looks much good. It looks great. See, when I compile, character just perform a stop animation and then a transition towards the idle. So for walk stop, we need a jog. Instead of jog forward to idle, we need walk forward to idle. So it is walk forward to idle animation. There we have. So I'm gonna grab the animation and paste it into walk stop. And for the start position, I'm gonna also set the start position to start from point 2. So now we have, when we enter in the idle state, first we have the stop state and then we transition towards the idle. So for transition towards idle will be pretty simple. This will be a simple transition rule. I'm going to set the automatic rule based to true. So when this walk stop ends, our character transition towards the idle state. That's it. And I'm gonna set the blend time to 0.35. You can notice over here in the viewport. So now if I hit play, see, when I hit play, our character just perform a real quick animation and then transition towards the idle, which looks pretty good. So now if I enter into walking mode, see, our character properly perform walk stop animation, and also the pivoting functionality works totally fine. So if we move forward and press the opposite key, our character just perform walk stop animation and then transition towards the opposite side.